So the rest of this lecture will cover everyone's favorite topic. Now, I'm not expecting you to like these, but I do want you to understand why they're important, particularly in a class that's all about quantitative measurements. So let's kick things off with our first clicker. Now, we will cover clickers in Zoom, but you'll always be able to at least see them in these videos beforehand. So what is the point of significant figures? A.
They are a cruel, perverse form of psychological torment created centuries ago by a secret coalition of warlocks and magi bent on world domination. Or
B. They relate to the accuracy of a measurement. So this one time, I'll actually give you the answer in the video because this is obviously a joke, and the answer is B. And we need to know that to inform the rest of our lecture. So they relate to the accuracy of a measurement. And for the rest of this lecture, I'm going to use a series of examples to build the list of rules. So it's kind of a different presentation than what you would see in a typical Gen Chem or A-Chem textbook, which is just, here's the rules. No, we'll try to understand them. And I'll warn you right now, on the first exam, I always put a more in-depth sig-fig problem that sees if you actually really get the logic of these, rather than you've just memorized the rules and you know how to apply them, which is also important. So let's say that we have a large cylinder, and we have this liquid that's somewhere in between 1 and 2 liters in volume. What could we say about the volume of that liquid, the volume of cylinder A? Well, we know it's greater than 1, it has to be. We know it's less than 2. Beyond that, we can clearly see that it's not even halfway to 2, so it's going to be less than 1.5, and it's probably larger than 1.2. So we can make an educated guess and say the volume's probably around the 1.3 or 1.4 liters area. But what if we were to try to estimate more accurately than that? What if we came up with 1.36? Well, let's analyze each of these numbers. Okay, the 1, that's good. That's certain. We know it's 1 point something. The 3, that's a reasonable guess. Reasonable estimate. But that 6? That's just nonsense. We're not even sure if it's 1.3 something as opposed to 1.4 something. We definitely can't guess anywhere beyond that 10th place. And so if I were to label each of these, I'd say the certain number is significant. The reasonable estimate is also significant. But this nonsense number, that's insignificant. And so ultimately, based on this cylinder as presented, we can only estimate to 2 sig figs. And we'll make the rule that the last sig fig represents the reasonable estimate. Last sig fig represents a reasonable estimate. Last sig fig represents a reasonable estimate. Now, what if we have the same volume liquid, but it's contained in a cylinder that provides more accurate readings? Like that one. Well, now we can look at this and come up with a number like volume of cylinder B is equal to 1.36. Because now we have more markings to give us some guidance. We know that that meniscus is between 1.30 and 1.40. The 1.3 is now certain, unlike before, and the 6 just became a reasonable guess. And so it is now significant. Anything beyond that, though, would be insignificant. Now, what if we changed the volume of liquid but kept using a cylinder with the same accuracy as cylinder B? And so, what is this volume? Volume cylinder C. Well, at first glance, you might think it's a 1.3. Seems reasonable. It looks like that meniscus is right on that 1.3 line. The thing is, we're still going to put in a 0. And that 0, even though it seems to go against all of the rules of math that you learned when you were younger, that 0 emphasizes the accuracy of this reading. If we don't put it there and we say 1.3, it's unclear if it's actually at 1.3 or if we're guessing it's around 1.3, like in this case. That 0 tells us that we are using a more accurate cylinder. Again, it's the same cylinder that we used over here. If this number could be guessed to the 100th place, this number can be guessed to the 100th place, since it's the same accuracy reading. And so this brings us to our first sig fig rule. Trailing zeros, i.e. zeros to the right of the last non-zero digit, are always significant if a decimal is present. So 1.500 has 4 sig figs. Those zeros are not random, they are emphasizing the accuracy of this measurement. Now, what if we wanted to change our unit from liters to kiloliters? What would we do? Let's use cylinder C's volume as an example. We would say 1.30 liters. And to get to kiloliters, we would go 1,000 liters on the bottom, 1 kiloliter up top. Do the math, and we get 0.00130 kiloliters. And so now our number has 6 digits. So did we just increase the accuracy of this reading? No, that doesn't make sense. It was a 3 sig fig number before. It's still a 3 sig fig number over here. Those extra zeros don't do anything. They've just adjusted the placement of that decimal to account for the fact that we are now using kiloliters. And so this brings us to our second sig fig rule. Leading zeros, i.e. zeros to the left of the first non-zero digit, are never significant. So 0.000173, all those zeros leading up to that 1, they're not significant at all. And that is a 3 sig fig number. Now what if we went the other way and went from liters to milliliters? So let's take that 1.30 liters and convert that to milliliters. We would go 1 liter on the bottom, 1,000 milliliters up top. My M's are really rough. And this will be equal to 1,300 milliliters. Now, how many sig figs are in this number? Pause the video and think about that. Okay, the shaky hands ruin the effect. The answer is still 3 sig figs, although those of you who remembered your Gen Chem rules probably thought it was 2. But that doesn't make sense. Let's talk about why. So in Gen Chem you would have learned that when there's no decimal, zeros to the right are not significant, and you would think this is a 2 sig fig number. But again, that doesn't make sense because we know that this number was 3 sig figs before. Well, changing the unit from liters to milliliters doesn't change the accuracy. All we did was change the prefix of the unit. This is still a 3 sig fig number, not 2. The Gen Chem rule does not work. And so what we really have here is an ambiguity, because if we were just presented with the number 1,300, how could we possibly know that this 0 here was significant? But this 0 here was not significant. Without that context of this initial 1.30, it's ambiguous. And so to remove the ambiguity, we use scientific notation. Instead of writing it like this, we should write 1.30 times 10 to the 3rd milliliters. And this emphasizes that our measurement is 3 sig figs. As for that 10 to the 3rd, the order of magnitude portion of this number, well, that's what we would call an exact number. And exact numbers are not subject to significant figure considerations because they are perfect and have no inaccuracies to them. We most often see exact numbers when we're counting objects. For example, there are 3 cylinders on this slide. there's no inaccuracy to that measurement. It's not like there's 3.01 cylinders. No, it's 3.000000000 ... an infinite chain of zeros to emphasize that there's no inaccuracy in that number 3. And so sometimes books will say exact numbers have infinite sig figs, but the way I like to think of it is they just don't get factored into sig fig considerations because there is no inaccuracy to them. And so let's summarize what we just covered with 2 new rules. Rule 3, trailing zeros are ambiguous, or if you're in Gen Chem, you consider them insignificant by default if no decimal is present. So in Gen Chem, you would say 12,000 has 2 sig figs, but in this class, we would say it could be anywhere from 2 to 5. And without more context, we cannot know. Rule number 4, exact numbers are considered to have infinite sig figs, or in other words, we don't consider them in our sig fig considerations. So for example, when we convert something to a percentage, when we do something like 0.65 times 100%, that 100% is not considered to be 1, 2, or 3 sig figs. It's infinite. It's a perfectly exact number. So our final answer would just be a 2 sig fig number, just like these were 2 sig figs. And our last rule doesn't really relate to these cylinders, but it's non-zero numbers and zeros in between non-zero numbers are always significant. So for example, 103, the 1 and the 3 are significant because they're non-zero, and since that 0 is sandwiched in between, it must be significant as well.